Hello, how you guys doing? Coming at you once again, lesson 2.4 and lesson 2.2, talking about the differentiation rules. There are several rules that are involved in differentiation. You have the constant multiple rule, power rule, sums and difference rule, product rule, quotient rule. We're going to look at all of the rules. So let's get started. Tonight I'm in a room that's extremely cold. It's cold in here, so I'm wearing my hat so I can stay warm, and my sweater so I can stay warm. It's kind of frigid. Okay? Well, let's get started. All right? So we're going to look at several examples. We're going to go over many examples, and we're going to apply all of these rules that are part of differentiation, various rules. So let's go. Number one, we want to, here we go, we want to differentiate. Or should we say, find the derivative. All right, here we go. Number one, if f of x equals x cubed, then its derivative, f prime of x, equals 3x squared. Take the 3 here times the 1 and subtract 1 from 3. This is what you get. All right. Number 2. If f of x equals 1 divided by x squared, first you have to rewrite the problem. Rewrite it and write it as f of x equals x to the negative 2. Now you're ready to find the derivative. And so f prime of x is going to equal negative 2 times x to the negative 3, which equals, and you have to simplify it or rewrite it again, which equals negative 2 over x to the power of 3. Okay? All right. Example 3. Now let's say we have f of x equal 4z squared divided by 5. All right, so first you have to rewrite it. And I would look at it as f of x equals 4/5. Put the z in the middle, z squared. See, if the z is in the numerator or off to the side, it's the same thing. It doesn't matter. Now let's find the derivative. F prime of z equals 2 times 4/5 times z, which equals 8/5 z. Example 4. F of x equals 3 pi x to the 5th. Well, then f prime of x, the derivative is take 5 times 3 pi, 15 pi, x, and subtract 1 from 5, and you get 4. Example 5. Okay, we have g of x equals negative x over 4 plus 3x cubed minus 2x. All right, well, this tells me then that g of x equals negative 1/4 x plus 3x cubed minus 2x. Now we're ready to find the derivative. And so g prime of x is going to equal negative 1/4 plus 9x squared minus 2. Okay? Because again, we're taking the derivative, it's the exponential power n times the coefficient, the lead coefficient. Multiply that, and then subtract 1 from the power of n, which is going to give me this term right here. Okay? Example 6. All right, we have y equal 5 over 2x squared, which equals, well, let's rewrite it. Let's rewrite it. So y is going to equal 5 halves times x to the negative 2. And now you're ready for the derivative. So my derivative, which is what we call y prime, that's going to equal negative 10 halves x to the negative 3, which equals negative 5 x to the negative 3, which equals, now you have to rewrite it again because you don't want to leave your answer with the negative exponent. So you have to rewrite it. So it's going to be negative 5 divided by x cubed. And that's the answer. Negative 5 divided by x cubed. Okay? All right. 7. Example 7. All right. We have y equals 7 divided by quantity 3x to the power of negative 2. Let's rewrite it. So we're going to have 7 times 3x quantity squared, which equals 7 times 9x squared, which equals 63x squared. Now we're ready to find the derivative. Let's find the derivative. All right. So y prime is going to equal 63 times 2, which is 126x. And that's the derivative. Okay? All right. Example 8. Let's change colors. Example 8. Now we have 1 divided by 2, the cube root of x squared. Y equal. All right, first, let's rewrite the expression. Rewrite the equation, rather. Let's rewrite it. So it's going to be 1 divided by 2 times x to the 2/3. So take your radical and rewrite the radical as a rational exponent, okay? So now it's a rational exponent, which is 2/3, x to the power 2/3. All right, let's continue to rewrite. This is going to equal 1/2 x to the negative 2/3. All right, now we're ready to find the derivative using the power rule. All right, let's do that. So y prime now is going to equal negative 2/3 times 1/2. which is going to be negative 2/6 x. And now you have to subtract 1 from 2/3. So now we have to consider negative 2/3 minus 1. What's negative 2/3 minus 1? Well, since this denominator is a 3, I'm going to express 1 in terms of 3. So that's negative 2/3 minus 3 over 3, which equals negative 5/3. Oh, there you go. That gets it. So my exponent right here is negative 5/3. And so now I can reduce it and rewrite. All right, so let's reduce and rewrite. If I reduce this, it's going to equal negative 1/3 x to the negative 5/3, which equals 1 over 3x to the 5/3. Now, that is the answer. That's correct. But notice this. In our problem, there was a radical in the initial problem. And so you might want to express the answer in terms of a radical if you can. Since that's how you started, then that's how you want to end. Now this is correct now, but it's only expressed as a rational exponent. Alright? But you can express it as a radical. And if you do that, it would look like this. So this answer would equal 1 divided by 3 times the cube root of x to the power of 5. Or you can write it as 1 over 3 times the cube root of x to the quantity power of 5. Either way, it's okay. Okay? Let's look at a few trig functions now. All right. Example number 9. Okay, let's say y equal x plus cosine x. Well then, y prime, the derivative of x is 1, plus, what is the derivative of cosine? What'd you say? Very good, negative sine. So it's going to be 1 plus negative sine x, which equals 1 minus sine x. That's the derivative of x plus cosine x. All right? And let's squeeze in example 10 here. Okay? Example number 10, we'll squeeze it in right here. Let's say y equals the sine x divided by 2, which is the same as y equaling 1/2 sine x. So y prime equals 1/2. The derivative of sine is cosine. And there you go. That's the end of that. And so that's using some of the basic, there's some basic problems using the rules of differentiation. Now we're going to look at a few word problems, okay? All right, let's go. Let's look at a few word problems. Let me erase this board, give myself some more room here. Look at a few word problems here. Erase the board. And we'll look at a few word problems here that involves taking a derivative. Okay, here we go. Word problem number 1. Find the slope of the graph. We'll call this example 11. Find the slope. Find the slope of the graph of f of x equals 2 cosine x at the point pi thirds 1 then find the equation of the line tangent to the curve or to the graph at the indicated point. All right, no problem. So first, we want to find the slope of the graph f of x equals 2x at the point pi thirds comma 1. So the first thing you want to do is find the derivative of f of x. That's first. This is an algebraic approach, not a graphic approach, but an algebraic approach. First, look at f of x. F of x equals 2 cosine of x. So its derivative, f prime of x, is, well, it's going to be 2, and the derivative of cosine is negative sine. So it's 2 times negative sine x, which equals negative 2 sine x. That's the derivative. All right? That's the derivative. And the derivative is a formula we use to find the slope. It's not the slope, but it's the formula that we use to find the slope. All right? So this right here is the formula used to find the slope. That's what the derivative is. The formula used to find the slope. So now, let's look at f prime of pi thirds, which is going to equal negative 2, the sine of pi thirds. So f prime of pi thirds equal negative 2. So now, what is the sine of pi over 3? Well, pi over 3 is the same as 60 degrees, and the sine of 60 degrees happens to be the square root of 3 over 2. Root 3 divided by 2. And the 2's here will cancel out, leaving you a negative root 3. Negative root 3. Therefore, 3 dots mean therefore, the slope of the graph and the tangent line at the point pi thirds comma 1 is m equal negative root 3. There you go. So negative root 3 is the slope of the curve, the cosine wave, and it's also the slope of the tangent line at the point negative pi thirds 1. All right, so we found the slope, but they also want us to find the equation of the line tangent. What's the equation of a line? Well, there's several ways we can go about it. We have the slope and we have a point. The slope, m, is negative root 3, and the point is pi thirds comma 1. There are two ways we can express an equation. We can express it in point slope form, That's one way. Or we can express it in point intercept form. That's the other way. So there are two ways we can express it. Point slope form or slope intercept form. Either way. Come on. All right, so let's look at point slope form first. Point slope form is y minus y1 equals m times x minus x1. We're going to say this y right here is fixed, and this x right here is fixed. So we have our m, we have our x1 and y1, plug it in. So we're going to have y minus 1 equals negative root 3 times x minus pi thirds. That's your equation right there. That's it. And if I continue now, if I solve this for y, that would give me point intercept form. If I keep working it through, I would have point intercept form. I'm sorry. No, not point intercept. What am I talking about? What am I talking about? It's not point intercept. It's slope. Pardon me. Slope intercept form. Okay? If I keep working this out, this would give me slope intercept form if I solve it for y. Alright. Well, here's what you know about slope intercept form. Slope intercept form is y equals mx plus b. Well, m is negative root 3, and our point is pi thirds comma 1. So I can solve this for b, plug everything in, solve for b. And so I'm going to have 1 equals negative root 3 times pi thirds plus b. So 1 is going to equal negative root 3 pi over 3 plus b. So b now is going to equal 1 plus root 3 pi over 3. All of this is b. And so now we take our b and our m, put it together, and there's your equation. And so y is going to equal negative root 3x plus 1 plus root 3 over 3 pi. And there you go. There's your equation. Okay? Now I did mention that we could get the same equation up here by taking point slope form and solving this for y. You get the same thing. In other words, take this equation here and tell me what does y equal. Solve it for y. Simply by adding 1 to both sides. Okay? And if I add 1 to both sides, I'll get the same thing that I have up there. Alright? It's the same thing. Okay. Alright, good. Alright, let's continue on. Let's continue. That was number 11. Let's see here. All right, 12. All right. F of x equals 3x minus 2x squared times 5 plus 4x. Now we have to use what we call the product rule. The product rule, okay? Because we have two factors here. All right, here's one factor. One factor is 3x minus 2x squared. That's one factor. And here's the other factor. 5 plus 4x. And when you multiply these two factors, you know, your answer is a product. So in order to find the derivative, we have to use the product rule. Okay? Let's see. And so the product rule states that f prime of x is the derivative of the first. The derivative of 3x minus 2x squared times the second, 5 plus 4x, plus the first itself, the first factor, 3x minus 2x squared, times the derivative of the second, 5 plus 4x. Okay? Now, it really doesn't matter which factor you differentiate first, the first one or the second. It doesn't matter because, in essence, we're multiplying. And multiplication is commutative. You know, 2 times 3 is the same as 3 times 2. So it doesn't matter which one you do first. Furthermore, the operation between the two products and the derivative is addition, which is also commutative. 3 plus 5 is the same as 5 plus 3. So order really doesn't matter in this case, okay? It's just that whatever order you do in one portion of the sum, do the reverse order in the second portion of the sum. All right, here we go. So the derivative of 3x minus 2x squared is 3 minus 4x. That's the derivative of 3x minus 2x squared. 3 minus 4x. And that's going to be times 5 plus 4x. All right? Plus 3x minus 2x squared times the derivative of 5 plus 4x. Well, the derivative of 5 is 0, and the derivative of 4x is 4. So it's times 4. Okay? The calculus is done on this problem. All the calculus is finished. Now it's a matter of doing the arithmetic, multiplying, combining like terms, and that's it. So let's do that. So let's multiply now. And so we're going to have 15 plus 12x minus 20x minus 16x squared plus 12x minus 8x squared. That's the multiplication piece. We multiplied. And how did you multiply? Here's what I did. I took 3 times 5 first, and then 3 times 4x, and then negative 4x times 5, and then negative 4x times 4x. And then I multiplied 4 times 3x, and then 4 times 2x squared to get that expression. Now combine like terms. Combine the square terms. A minus 16x, a minus 8x is a minus 24x squared. Now do the x's. 12x minus 20x plus 12x is going to give me a plus 4x. And bring down to plus 15, and there's my answer. That's the derivative. Okay? Let's do some more with the product rule. All right, now, number 13, let's take a look at, let's see. Let's look at y equal x sine x. All right? So I have two factors. I have x times sine x. That's the product here. It's x times sine x. Those are the two factors here that we're multiplying together to produce our product. All right? And so, y prime, the derivative, is going to equal the derivative of x times sine x plus x times the derivative of sine x, which equals 1 times sine x plus x, and the derivative of sine x is cosine x. Final answer, sine x plus x cosine x. And there you go. That's our final answer for that. All right. 14. Let's look at another example. 14, let me see. Okay. Let's say y equal 2x cosine x minus 2 sine x. Another example. Let's take a look at it. All right? Here, we have to use the product rule. Okay? We have to use the product rule. Because we have two factors here. One factor is 2x, and the other factor is cosine x. Let's go. And so y prime is going to equal the derivative of 2x times the cosine of x plus 2x times the derivative of cosine x. All right, so far, this takes care of my product rule portion, minus the derivative of 2 sine x, minus the derivative of 2 sine x. Let's do the calculus now. Let's find these derivatives. Here we go. Y prime equals, the derivative of 2x is 2 times cosine x plus 2x. The derivative of cosine is negative sine x. The derivative of cosine x is negative sine x. All right? Minus the derivative of 2 sine x, which is going to be 2. The derivative of sine x is cosine x. So y prime is going to equal 2 cosine x minus 2x sine x minus 2 cosine x. And if you notice, cosine x minus cosine x, they cancel out. So 2 cosine x minus 2 cosine x cancels out. And so y prime simply equals negative 2x sine x. And there is the answer. It's not too bad. It's pretty straightforward if your derivative is correct. You shouldn't have much of a problem if your derivative is correct. All right, now let's move into the quotient rule. Okay? The quotient rule. And that's going to be example 15. The quotient rule. All right? So example 15, we have the quotient rule. All right. The quotient rule. Now, with our quotient rule, there's something I want you to remember when you have to find the derivative of a quotient. All right. Here's what I want you to remember for the quotient rule. I want you to remember to find the